Chapter 4 is about an introduction for the time value of money. Time value of money is one of the most fundamental concepts in modern finance. So, to start, let's think about the question. Would you prefer to have 1 million now or 1 million 10 years from now? I think the answer should be pretty straightforward. Any rational person would prefer to have $1 million right now, like immediately, instead of having to wait for 10 years. So that gives you the idea that $1 million now was more than $1 million 10 years from now. And so 10 years, the time matters, or the time actually affects the value of cash flows. So the basic idea behind the concept of time value of money is that $1 today is worth more than $1 promised for later. That is because a dollar received today can be invested to earn interest, or say a return, and the amount of interest earned depends on the rate of return that can be earned on the investment. So in this process, how much this time matters actually depends on the size of the cash flows. So apparently $1 million was more than $100,000, and so if you are talking about $1 million 10 years from today, it still was more than $100,000 10 years from today. And the time between cash flows, so if we are talking about 1 year, or if we are talking about having to wait for 10 years, you understand that that actually would be different. Also, the rate of return. So if I can use my money, invest my money, and make a 10% return, versus the case that I can only make a 4% return, you can understand that that would also affect the time value of money, or say affect your decision when you think about whether you want to wait or not. So time value of money, as I said, is one of the most fundamental concepts in modern finance, and it is applied in all aspects of finance, including bond valuation, stock valuation, capital budgeting decisions, financial analysis of firms. So all those we will talk about the application in the later chapters. And also in chapter 5, you will see we applied the concept of time value of money in your mortgage payment questions, in your car payment questions, in your retirement planning. So it can be applied in many other ways. So before we start talking about the calculation of time value of money, let's introduce a very helpful tool to analyze the cash flows. This is called a timeline. A timeline actually is pretty simple. It's nothing but a straight line, and on this straight line you see time. So time 0, that means today or now, and time 1 here means 1 year from today, and apparently 3 here means this is 3 years from today, 3 years later. And then we try to line up cash flows along the time. So if we have $100 here, that means now we have $100. And any cash we receive is called an inflow, and it's represented by a positive number. So a positive $100 here, that means you have, or you will receive $100. In this question, we will calculate the future value in 3 years for this $100. We'll do the calculation later. At this point, we look at how to construct a timeline, or say how to use a timeline to identify the cash flows involved in time value of money questions. So now if you are asked to draw a timeline for an investment of $40,000 that returns nothing in 1 year, and $20,000 at the end of the second year, nothing in year 3, and $40,000 at the end of year 4. So notice this $40,000 is an investment, or say cash outflow. So that's why at time 0 you have a negative $40,000, and then year 1 nothing, year 2 a positive $20,000, and then year 4 a positive $40,000. So again, this is how we construct a timeline, and we line up the cash flows with the time on this straight line. It doesn't matter whether you have the time on the top or below. It's either way is okay. You just need to line the proper amount of cash flows with the time when it occurs. Now let's try to think about the future value of a single cash flow. If we invest $100 today in an account that is earning 5% rate of return per year, can we calculate the future value in 1 year? This is actually a very simple question. Think about $100 earning 5% return, then you are actually making a return or interest of $5, right? This interest of $5 add to the principal of 100, you will have 105 in total, principal plus interest. You can also write the interest amount in a way so that this 105 is calculated as 100 multiplied by 1 plus the interest of 5%. So this is for 1 year, and in general we have the future value, in our case 105 here, as the present value, in our case 100 here, multiplied by 1 plus I, the interest rate at the power of n. In our case n is 1 year, so we do 100 multiplied by 1 plus 5%. Now if we have 2 years, then n will be 2, and what we get is 100 multiplied by 1 plus 5% at the power of 2, so we get 110.25. So this $10.25 represent $10 earned on the original $100 interest. Remember, there are 2 years, each year $5, then a total of $10 in 2 years. But then there's another 25 cents, and this 25 cents is the interest earned on the $5 interest from the first year. So you get the idea that we are earning interest on interest, and that is the idea of compounding interest instead of simple interest. We can also use the financial calculator to perform this calculation. I have another video posted on D2L to explain how to use your financial calculator, including a TI-BA2 class or a TI-83. So depending on what kind of calculator you have, please check out the video that explains how to use the financial calculator. For this video, I'll just briefly go through what you have to input into your calculator to get the results. If you want to calculate the future value of $100 in 2 years based on 5% interest rates, you input 2 as n, that's 2 years, 5 as IY, that is the 5% interest rate, $100 as PV, present value. You leave payment at 0 because there is no other payments, and you compute future value, and the result is a negative 110.25. At this point, you do not have to worry about the negative sign. You just have to take the amount, which is 110.25, as the future value, which is consistent with the result you got based on the formula. What if we leave the deposit in this account for 5 years? So now n will be 5, and based on the same formula, 100 multiplied by 1 plus 5% at the power of 5, you end up with 127.63. If you use your calculator, you see that we change n from 2 to 5, and now future value is about 127.63. So now we look at some example questions. This is an example for -1 from your book. If this guy asks his parents to lend him $1,500, so he's gonna receive $1,500 today from his parent, and then he promised to pay back in 3 years. So if his parents charge him 7% interest rate per year, then in 3 years, how much would this guy need to pay back to his parents? This is actually a question about the future value of this $1,500 in 3 years. And also the question asks how much interest will he pay, and how much of what he pays is interest on interest. So let's see. 1,500 present value, because that's what he's getting now from his parents. Based on 7% interest rate, 3 years later, the future value is 1837.56. That means he owes his parents 1837.56. And comparing this number to the 1,500 principal his parents lent him, so you understand this is the total amount of interest that he has to pay, or say generated in 3 years from the 1,500 principal. Now, part of this 337.56 is interest earned on interest. So if we think about it, each year the principal is 1,500. 7% of the principal is 105. So 3 years altogether, interest generated on the principal is 315, which is 3 years, 105 each year. Now this is lower than the total interest of 337.56, and the difference is apparently generated from interest, or say interest on interest. So this is how we think about future value, and think about interest from interest, or say the compounding interest from future value calculation. So if you are interested in watch the test publisher provided video on how to get the results, you can click here. Depending on what kind of calculator you have, and the first video is actually based on using the formula. Now if you want to see how to use your financial calculator, depending on what kind of calculator you have, you can click on specific link to go to the video that shows how to use your calculator to solve this question. Now, compounding interest is actually a very important or powerful tool for building wealth. Einstein supposedly have said that the most powerful force in the universe is compound interest. As you see, I said composedly because actually there are also people arguing that he actually never really said that. But anyway, this is just to show you that it is accepted that compounding interest, or say interest on interest, can be very powerful in terms of generating future value and building wealth. We're going to look at several more examples to show the power of compounding, or say how time matters, the number of years matters in future value results. So the first question here is, what is the future value of 100 if it's invested in 20 years at 5% interest rate? So by now you should be pretty familiar with the calculation, and you can calculate the future value result. It turns out to be 265.33. Now what if we double the time to 40 years instead of only 20 years? 20 becomes 40, and you calculate future value with interest rate and present value keep constant. Your future value now is 704. So if you think about 20 versus 40, the number of years doubled, but the future value actually more than doubled. So that's why we say the time value of money relationship are not linear. So when n doubles, your future value again more than doubled, and that's why we say they are actually exponential. What if we change the interest? So if we are looking at 40 years, but if the interest rate changes or say doubles from 5% to 10% per year, now you see the future value becomes way larger. So we're looking at 4,500 instead of 700. This is about 6 times instead of just doubled. Okay, so again, interest grows exponentially, and then even a small change in the interest rate can cause a big change, a dramatic change in the future value. So it's again more than doubled, the future value more than doubled. So now if you stop and think about the following question: what factors would affect the future value of a single cash flow? Think about the formula to calculate the future value. Remember, future value equals to present value multiplied by 1 plus I at the power of n. So then the amount of present value, or say the amount of cash flow, apparently matters. Then think about the n, time apparently matters. And think about the I in that formula, interest rate apparently also matters. And if you think about this, is to echo with what we mentioned at the beginning of this chapter. Well, we briefly mentioned at the beginning here that the size of the cash flows, time, and interest rate, these 3 factors together, they affect the future value. Now, what if the interest rate actually changes over time? In the previous example, we assume that the interest keep constant 5% all the time per each year. So now what if we have changing or varies interest rate? That's actually also pretty straightforward. If it changes, then year by year we use the different interest rate provided, and we calculate the present value accordingly. So if we have a 2,500 present value, actually here it should be future value. If we have 2,500 present value and 7% interest rate for the first year, 8% interest rate for the second year, and 8.5% interest rate for the third year, then compound year by year, we have the future value of more than $3,000. So this is just another example. This example is about the interest rate increase year by year. So it starts with 7% and then becomes 8% and then 9% later. So you just calculate the future value according to the different interest rate. If you want to watch the video, it's here. We just talked about calculating future value, and now let's think about calculating present value. So the process of finding the present value of a future cash flow is called discounting. This is opposite process to compounding. So discounting is to calculate present value based on the future value amount, while compounding is to calculate the future value based on present value amount. So a very simple example here. If I want to have $100 by the end of the year, so not today, but by the end of the year at 5% per year, so how much do I have to deposit now? Whatever I deposit now will generate a 5% return, so that I can have $100 principal plus interest in a year. So how much do I have to deposit? That is a typical present value question. And if we think future value equals to present value multiplied by 1 plus I, this is 1 year, so n equals to 1, right? And then we calculate present value. Present value turns out to be $95.24. So $95.24 in this account, generating a 5% return, will together give us $100 in 1 year. Again, this process is called discounting, and it's actually based on the same formula, but now we're just using the future value to calculate the present value. So in general, present value equals to future value divided by 1 plus I at the power of n. If we discount the deposit for 2 years, so n equals to 2, then the present value is $90.70. If we discount it for 5 years, then as you see, present value is $78.30.